Okay, so in order to understand how I'm going to interpret cognition, let's go a little further into the conceptual framework. Besides schemas, which we've done already, number 2 is reasoning models. It turns out that in the work we've done, from studying various people, and here Adriano Andrea has also been made some really good contributions. These tend to be the most useful reasoning modes that enabled us to interpret what's going on. They emerged from the study, but I'll present them to you straight up front. I'll come to them. You don't worry about them now, because I'm coming to them one by one. Principle-based reasoning is exactly what it says. As you'd expect, the normative solution. If you want an example, then the problem about the acceleration of an object, the systematic principle-based solution would be identify the system, the object, identify the forces on it, draw a force diagram, figure out the net force from that, and from the net force, using Newton's second law to provide the acceleration. Sensible, straightforward. That's principle-based reasoning in a simple example. And that's what our solutions look like. So there's a great emphasis on principle-based thinking in most courses. Case-based is our second one. What we mean by case-based is that when you're faced with a new problem, what you do is you say, oh, instant recognition, this looks like a case I've seen before. And you have no control, for the most part. That whole case comes into your mind because it's stored in your schema somewhere. And you say, oh, it's pretty similar to that. So I'll use that case. Can I use it as it is, or maybe I have to adjust it? And so you start your thinking by drawing in a case. The advantage of that is that whatever steps you went through in the previous case are all there, compiled, pre-assembled. You don't have to start from scratch, from principles. So it's quick, efficient, and dangerous. Because if the cases are different, well, you might run into trouble. Unless you're an expert that knows the dangers. So here's an example. This is the only time when I'm going to show you some student reasoning. Most of the time it's expert. So, but just to show you the student reasoning. It's also to show you some of the research we've been doing just quickly. Third mirror problem. And I'll show you case-based and principle-based at work. Here's the problem. The problem is basically a point source, the right, concave mirror, and the task is to find the image using ray tracing. Those people who read physics will know exactly how to do that, so I'll just do it quickly. Draw a couple of rays. One ray reflected, another ray reflected at a right angle, and you get the image. Okay, for those that aren't in physics, I won't worry. We'll want to see that again? Yes. You just reflect two rays, obeying the law of reflection. Which locates the image. Now, that's the solution, and that's what a student produced using PPR in an exam. But had some second thoughts. Crossed out the image and the rays and did that. And we were completely mystified as to where that could possibly have come from, since she clearly knew how to do the problem. You could see the eraser. So we looked further into this and found that other students had done it too. It came from recording previous cases. And this is what happened. She clearly was able to do this. But questioned the position of the image because she did not expect an image to occur like that in front of the mirror. Different from the recalled place, which was a closer source. Here's the correct principal solution. And the image location. So, she faced a dilemma. Her principle-based reasoning and her case-based reasoning is giving different answers. She had to make a choice, and she went with what she remembered. She wasn't yet confident enough in her own principles. So it shows the strength of case-based reasoning in cases like that. Okay, just a couple of quick ones. Analogy-based reasoning. This will be obvious to everyone. If you're faced with a problem, it might look like some other situation. In some respect, either surface features or deep features, and you say, oh, it's like that. And you start working immediately on the basis of the analogy instead of from basic principles. Very powerful. Here's an example which physicists will recognize. If you're calculating electron beam diffraction, you can just pull in whatever you know about projectile motion. You don't have to start from scratch again. All the conceptual understandings are there, ready to access, so why start from scratch again? Also, the idea that the two are analogous enriches your understanding of both, so it's good stuff. And I bring in just another example because Al asked me about a year ago some question about Nicholson-Morley stellar aberration question. And I insisted on rowing a boat across a river or up and down street to look at that problem. And the interesting thing is that neither Al nor I remember the exact problem, but I remember very clearly that I used analogy-based reasoning. In fact, it wasn't just to tell me the method, it was to tell me that the method which I then applied. In fact, I just did the whole problem through rowing boats and then transformed the result through light, which was very interesting to me at the time. Faced with that. Anyway, it's also a very powerful type of reasoning. It's just not in solving problems, but it's pretty good for. It's just throughout the development of science. Nuclear physics, liquid drops, cloudy crystal balls, they're all analogies that provided very useful models for some abstract system that we never could see. So, nice kind of reasoning. I won't say anything about this, but it's transferred from one thing to another. Experiential intuitive. Well, what this means is that when you're faced with a new situation, you've had lots of experience of the world, intuitions about the way the world works, and you just pull them in and try to apply them. Here's an example. In dynamics, everyone knows that pushing a box across a floor requires a constant force. And therefore, it's a primitive, so-called phenomenological primitive, or Q-primitive, that essentially says, I don't know the way the word works, question mark. On the other hand, you might think that this kind of misconception would be harmful, but the same person, very same person, if you ask them a slightly different question or a different way, in their schemas, you've got something else